So we got a lot we could talk about today, or whatever, a little few things, but we have a test next class, test on chapter 3, Tuesday. Listen, you should bring a Scantron again, yeah, bring a Scantron. But I think part of this test is going to be multiple choice, like the last test, but I think part of this test is going to be some of my stuff. So it could resemble that quiz, which I'll give you back later. Could resemble some stuff in 3.3 that we talked about, our library of functions. Anyway, so kind of whatever. It'll be a little different test. Part of it will be similar, and then part of it will be kind of some questions. I couldn't find good questions in the testing system that I liked, so I'm gonna have to come up with my own stuff a little bit. But we'll probably use a Scantron for part of it, and then you probably show your work for part of it. So that's Tuesday's test, so you'll be fine. But there's one topic that, and maybe one or two questions, I don't know, that show up on the test that I haven't got to yet, and that is in 3.4. In 3.4, they have some questions like this. Just a few. There's only a few in the homework, and maybe you've looked at them, but maybe you haven't yet. The question is, here's a little bit of data, and they want you to find the equation of the parabola. Now, there's a lot of different ways they could word this, but they could say find the quadratic equation. Let's just say it like that, maybe. Find the quadratic equation that fits this data. Or that fits these points, or fits this data, or fits these points. There's a lot of different ways to talk here. But I want the quadratic equation, which is the parabola, by the way, we know that. If it's possible, and I just made this one up, I'm worried I could have made up one that's impossible. But let's see this is interesting. This is backwards, Usually I give you the equation and I ask you for the vertex, I ask you for stuff. Now, I'm asking you for the equation and all you have is a little bit of data. I tell you what I'm going to do. This might be irrelevant part of this, but I'm going to sketch a little picture of this. I just want to plot these points. 0, 3 is right here. -1, 5 is here. 4 and 20 is way up here. Way up there. So I don't know, is there a parabola that fits that? I hope so. Maybe there is. Maybe I've created an impossible situation here, I'm not sure. But I'm looking for the equation of the parabola. Here's what I would do, in case you have no clue what to do. Maybe you have a clue what to do, but here's what I would do. I would say, okay, he's looking for the equation of a parabola. In generic form, here's a parabola. Here is a parabola, ax squared plus bx plus c. So he wants this equation of a parabola. Okay, well then really what that turns out to mean is he wants a, b, and c. Can we find the a, b, and c that satisfies this data? Well, maybe we can. It's typical in mathematics when you kind of have an unknown equation with unknown coefficients. If someone gives you points, or x and y values, or ordered pairs, you know what you can do with those?
Plug them back into the equation.
You can plug them in, right? And for x and for y. And if you plug them in for x and y, it'll lead you to an equation with an unknown a, b, and c. Now that's 3 unknowns, a, b, and c, but if you have 3 equations with 3 unknowns, it's solvable, maybe. So that's my strategy. In case you didn't hear that, here's what it means. I'm going to plug in these points for x and y and see what types of equations it generates. What's very nice and makes this problem very nice is this 0, 3. That makes it a lot nicer. Because if you plug in a 0 for x and y is 3, watch what happens. Y is a 3, I'm plugging in a 0 for x, I'm plugging in a 0 for x. Guess what I just learned?
Y-intercept.
I learned that C is 3. Maybe, and the y-intercept is 3, that's true. This number is a 3, that's true, that's what I just learned. So now I don't really have 3 unknowns. Now I got 2 unknowns, A and B. I think maybe these other 2 points, so this was very useful. That was awesome. I think these other 2 points might help me find A and B. Let's see what happens. If you plug in a -1 for x, y is 5. Okay, I'm going to try that. Plugging in a -1 for x, that's -1 squared, that's just 1a. A -1 for x makes that a -b. Oh, and don't forget that the c, we already know the c is a 3. I'm going to plug in a 3 for c. So here's an equation with 2 unknown variables. I wish I had another equation with 2 unknown variables. Well, I'll plug in this other point. Let's try this one. This says that when y is 20, x is a 4. Okay. If x is a 4, that's 4 squared, that's 16a, plus 4b, and then don't forget c is a 3. All right, this is awesome. Here's another equation with 2 variables. Hey, we practiced this in Chapter 2. How do you solve 2 equations with 2 variables? You can solve 2 equations with 2 variables. It's called solving a system of equations. We can probably solve and find A and B. We practiced that in Chapter 2. We could maybe substitute, maybe we could eliminate somehow, substitute. We can somehow solve this. Here, I'll help you. Let me see. First of all, maybe I'll move the 3 over so I can get it. 2 equals A minus B. If I subtract the 3, if I subtract this 3, it'll be 17 equals 16A plus 4B. Yeah, I'll tell you what, it's pretty easy to sub. You know what I think I'll do? I think I'll just add this B over here. If I add this B, then what's A? A is, hang on. If I add the B, A is B plus 2. Are you guys okay with that? If I add the B, add the B. A is B plus 2. I think I'll substitute, that's what I'll do. I'll substitute that for A. Okay, here I go. 16 times A plus 4B, but that A is a B plus 2. Hey, I should be able to find B. I should be able to find B. It might not be pretty. What is this? 16B plus 32 plus 4B. If I add up the B's, that's a 20B. If I subtract the 32, that's a -15. If you divide by 20, B is -15/20. Or reduced, it's a -3/4. That's awesome. If B is -3/4, let's go up here and plug it in, and A is -3/4 plus 2. And that's 2 over 1. You got to get a common denominator. 8 over 4. 8 over 4 plus the -3 over 4. I think A is 5/4. That was awesome. I mean, there's work. It took some work. But I like that. That's pretty cool. Given 3 points, you should be able to find the equation of the parabola. And you should probably use this method that I outlined here for you. Start with a generic unknown parabola, plug in the points, and find A, B, and C. So the answer is what? The answer is the parabola with the A, B, and the C filled in. The A was 5/4, so 5/4 x squared plus B was -3/4 x plus 3. Yeah, this was my A, B, and C. This is the parabola that hits those points. Probably kind of looks like this, I guess, unless I don't know. I could go find his vertex. I don't need to do all that. I just wanted to find the parabola that fits these points. This is a new topic. This is up in 3-4. I haven't practiced this with you, but now I have. The homework has 2 or 3 or 4 of these. I'll probably put one of these on the test. Any questions about it? You got the strategy? they'll say find the equation of the parabola. It'll be up to you to sort of write this down and know how to use it. I mean, they won't really give you this necessarily. So you come up with this idea and plug in the points and find A, B, and C. Yeah. It gets tougher if they didn't give me one. If this was nice. This was so nice. Again, because what it did was it gave me C right off the bat. And then all I had to do was find A and B, which took some work. If I didn't know C, then I'd have 3 equations, 3 unknowns. It would be a little tougher problem. In fact, we haven't even practiced that. So I don't want to do that to you. The homework might. I don't know if you've done any homework, but it might. Well, good. I could practice another one of those, or I could move on. Do you guys have any questions on anything? Trying to pull up some homework here, see if there's anything I see. I helped you with some homework the other day. Yeah, here's one. Let's just try this. This is in your homework. This might be, maybe this is too advanced for the test. But in 3-4, let's just try another one of these maybe. And I just found the last one in 3-4. It might be a little tougher. It's got this one I'm looking at has a -3, 40, 1, 4, and 2, 10. They have these 3 points: -3, 40, 1, 4, and 2, 10. So they're giving me these 3 points, and it's really the same game. Find the equation of the parabola. See, they didn't, and I don't know if any of them, they're given 3 random points. I kind of doubt any of them is the vertex. If one of them was known to be the vertex, that would kind of help. That would make life a little easier, but I don't think I know that. Let me just plot them too, just see what they look like. Hang on. -3, 40, -3, 40, that's way the hell up here. 1, 4 is right about here, maybe, well, or less. And then 2, 10, okay. All right, well, yeah, I can sort of see how a parabola could fit there, What'd you say? It doesn't look like it could be to me, just kind of the look of it. It could be, but there's nobody said it was. We can't assume it is. The way it looks to me, I'm sort of feeling like maybe it looks like this and the vertex is over here somewhere. But that kind of doesn't matter. I mean, when I plot these and sort of try to sketch it, that really doesn't help me solve it much. I mean, I'm just doing it to show you what's up. But this doesn't really help you solve it much.
So we could create our own vertex, right?
No, we got to find the parabola that fits these points, and the strategy would be the same strategy I just did. We don't really know the vertex. We're not going to use the vertex to help me at all, really. It's just a matter of using this equation to try to find the unknown A, B, and C. Like I did, except this one's tougher. What made this one so easy is when I had that 0, when I could plug in a 0, I got C right off the bat. That helped a lot. I still had my work cut out for me to find A and B. But now my work's even more. Let's check it out. Watch what happens when you have these 3 points. And this is like I said, maybe, again, I mean, you're smart algebra students, you can do this, but in a way, it might be something we haven't done yet. Here I go. I'm plugging in a 40 for the y, and I'm going to plug in a -3 for x. That's going to give me a 9a, a -3b plus c. That's what happens when you plug a -3 in for x. I'm going to plug in a 4 for y. That's a 4 for y, and a 1 for x. It's nice to plug in a 1 for x. That's easy. When you plug in a 1 for x, you just get a plus b plus c. All right. I'm going to plug in a 2 for x, and the y value is 10. I'm going to plug in a 2 for x. That's going to give me a 4a, because it's squared, a 4a, a 2b, and a plus c. Yeah, so here I am, you guys. All of a sudden, I'm solving 3 equations, 3 variables. And I haven't ever really showed you how to do this. Would you like me to show you? Maybe I should. Well, the strategy is not that hard. Going through all the work takes a couple pages. No, page. The strategy is this. Use your elimination method and grab 2 of these equations and eliminate c. And then what you'll have when you do that is you'll have an equation with just a's and b's. Then grab the next 2 equations and eliminate c. Then you'll have an equation with a's and b's. Now, do you hear where you are now? Now you're down to 2 equations with 2 variables, and you know how to do that. So that's the game. It's kind of a pain, but that's the game. Now look, how am I going to eliminate these? So what I used to do I would add them together. So maybe you would suggest that I multiply somebody by a negative and add it to the other one, right? To eliminate c. So without a lot of writing, can I sort of do that in my head? Let's see. I think I'm gonna multiply this bottom equation by a negative, and I'm gonna add it to the top equation. You could say I'm gonna subtract this from the top equation. Yeah, but you could say that. I'm subtracting the second equation from the top equation. The result is 36, if I subtract, 8a, and when you take a -3b and subtract a b, that's a -4b. So by subtracting these equations, you got rid of c. You eliminated c. All right, I'm going to do that again with these 2 equations. Now I'm going to do it with these 2 equations. I think I'll subtract that middle one again. So this time I'm subtracting backwards. The bottom equation, subtract the second equation. So 10 minus 4 is 6. 4a minus a is a 3a. 2b minus b is a b. And when you subtract the c's, they've eliminated. And so here you are now solving 2 equations, 2 variables. And we kind of know how to do that. You could do more elimination method here. I would substitute, I don't know, I see that it's easy to solve for b right here. B is 6 minus 3a, if I move the 3a over. So I think I'll use that and plug it in for that b. Oh my God, here we go. So 36 equals 8a minus 4b. But what's b? What's b? What's b? 6 minus 3a. All right, we're making progress. I can get a now. I can get a. 36, 8a minus 24 plus 12a. Let's add the 24 over. When I add the 24 over, that's 60. When I add these a's together, that's 20a. When you divide by 20, we just found out that a is 3. Woohoo! I'm not sure if you're with me or ahead of me, but you guys okay? Any questions? I just found that a is 3. The following steps are going to be real easy. Now that you know A, I think I'll go way back here and find B. Right here it tells me that B is 6 minus 3A. B is 6 minus 3 times A. So if A is 3, here comes B. That's 6 minus 9, that's a negative 3. Awesome. Now you got A and B. If you got A and B, you can go back to one of the original 3 equations, and I think you can get C. I think I'll go for the middle equation here. The middle equation says that 4 equals A, which is 3, and B, which is a negative 3, plus C. Well, okay. Using that middle equation, I'll be darned. Those 3's cancel. It looks like C is 4. I found C. That was solving 3 equations with 3 variables. Don't worry, I won't ask you to do 25 of these problems. Here's one. The answer then is the equation of the parabola with the A, B, and C filled in. That's awesome. We found the equation of the parabola. Given 3 points, you can find the equation of the parabola. It is 3x squared minus 3x plus 4. That's my A, B, and C filled in. This parabola hits these points perfectly. Perfectly. So that's that little 3-4 that I never got to. Now that I'm there, I like it. It's cool. Look for maybe one question like that or something on the test. I could do the tougher version or the easier version. I did both here today. Okay. You guys all right? Yeah. You know what? There's only 4 questions in this homework. I just found another one here that's a word problem. Let's talk about this a second. We're still just sit here in 3-4 a second, and we'll do another one. The one I just found is a word problem. I'm looking at your homework. I'm not projecting it up here. I'm sorry. This one says a ball is thrown from the top of a 240-foot high building. It's 256 feet above the ground after 1 second. And it reaches the ground in 5 seconds. Hey, hang on. Look what they just told me. And I like drawing pictures. I don't know about you guys, but they're throwing a ball off a building, and I think they said it was a 240-foot tall building. Let me read this again. A ball is thrown upward from the top of a 240-foot tall building. So I think this problem sort of starts here when the ball is thrown, x is 0 or t is 0, the height is 240, and we threw the ball up. And then the ball comes and hits the ground. So in a way, they gave me a point right here. Can you tell me the name of this point?
0, 240 with the white.
Thank you. Thank you. I'm calling it 240, and he just added the 0 in there for me. That's what I was kind of asking for. Yeah, thank you. And they gave me another point. They said after 1 second, it's 256 feet tall. I mean, I could put that on the picture, but more importantly, it's a point. After 1 second, it's 256 feet high. And then they said it hits the ground in 5 seconds. It hits the ground in 5 seconds. Can you tell me the name of that point?
50.
Oh, thank you very much. 50, right. They didn't say that, but they said it hits the ground, and we should know the ground is 0. The ground is a height of 0. Well then, with those 3 points, maybe I just played the same damn game. Is that what I do? Mm-hmm. Except it came from a word problem. Yeah, maybe I do. Again, with having some zeros in there helps the game. All right, I don't know if I want to do another one of these. I've done plenty. Yeah, I gave you 3 points. You can treat it like this, or what you could do, what you might feel tempted to change the x to a t, but that doesn't really matter. You can call this the x-axis, and x is time, or you can call it t for time, but you would play the same game. Plug in y's and x's. Right off the bat, the c is 240, I think, right, you guys? The c is 240, and then you got to use those other points to find a and b. Yeah, I think I'll just leave you with this one. They do say use x as the variable. Okay. Okay. All right, that's 3-4 then. Is anything in 3-3 bothering you? I tried to help you with 3-3 a little bit. Yes, sir?
For problems that say to use a graphing utility.
Yeah. So, so in this class, in this class, you don't have to have a graphing utility. This is a graphing utility, $120 graphing calculator, or whatever it is nowadays. So you don't have to have one in this class, and I've been teaching you how to do stuff without one, definitely. So, but the book kind of thinks you have one sometimes, and the My Math Lab makes reference to it sometimes. So please ignore that. So don't use a graphing utility. Just plot some points, use your knowledge of what the graph looks like. I think the problems I assigned, I was kind of careful when I picked these problems. Even though it said graphing utility, I thought it looked like something you could do without a graphing utility. So I picked it anyway. But in general, I tried to avoid questions that said use your graphing calculator because I knew you didn't have them. But occasionally I thought maybe you could do it anyway. So that is good. That's going to be true all semester. When your book or your My Math Lab refers to a graphing utility, maybe ignore them and do the problem based on how we know how to do it in class. So does that help? Or?
Yeah, that helps. Thank you.
Yeah, okay. Here, maybe I will turn this on a second. Oh, it is on. That's not good. Right. Well, that's another thing we should talk about is your quiz you took the other day. Yeah, I can hand those back and talk about those and help you with those. That was part of my plan today. This is working. Okay. I think it was left on and then it shuts itself down and then I turn it back on. Anyway, it's working. Hey, here's one of these variation questions in 3-3. I only practiced one of these with you the other day, I think, barely. Let's work on this one. I found this in the homework in 3-3. It says, if y varies inversely with the square of x. So, again, I barely helped you the other day, but I had some good notes on what that means. If you paid attention, you could handle this. But I'll help you. When you read that first part of the sentence, you should write an equation. And here's the equation you should write. Y equals, it varies inversely with the square of x. Okay, well, first of all, varies inversely means, well, first of all, I'm going to introduce a constant k. There's an unknown constant k. It's called the constant of variation. But if it was direct variation, then it would be multiplied by the square of x. Because it's inverse variation, it is divided by the square of x. So it's k over x squared. And that's because of the word varies inversely. One little word change, listen, varies directly would be this. Y equals k times x squared. That's varies directly, that's varies inversely. That's all. By the way, what that means is that when things have a direct relationship or vary directly, when this quantity grows, this quantity grows. When this quantity decreases, this quantity decreases. They have a direct relationship. When they have an inverse relationship, when this quantity increases, the y decreases, and vice versa. So they have an inverse relationship. It's worth mentioning. But anyway, this problem says when y varies, I mean, it's not that hard, but it takes a little practice to write that sentence. Now, watch this. Now, it's real subtle. The next little phrase here, when y is 6, x is 2. Well, that's a piece of information that you should plug in for x and y, and that will help you find the unknown k. I think I'll do that. When y is 6, x is 2. That's 2 squared, which is 4. You can find the unknown k doing just baby algebra here. I would multiply by 4, and k is 24. Now you know k, so what you have is not a generic relationship anymore, but more specific relationship for this problem. You have y equals 24 over x squared. That's the relationship. That's the actual relationship between y and x for this problem. And everything's cool, except guess what? They're about to ask me a question. So now they ask me this question. Find y when x is 0.5. So now I can answer it. I kind of couldn't answer it a few minutes ago because I didn't know what k was. You know, without knowing k, I can't really get the answer. But now that I know k, I can give them an answer. Find y when x is 0.5. Okay. Find y when x is 0.5. You know, I pick up my calculator to tell you the truth, but that's a 1/4 is what that is, and when you divide by it, you're really kind of multiplying by it. Anyway, I think it's 96. You guys think that's right?
Yep.
Cool. So that's pretty cool little problem. It is a little 3-step problem. Kind of like I said before, it's subtle, it's quick though. It's all in one quick sentence, but there's 3 steps there. You write down the generic equation, they give you some information to find k, and then they ask you a question. Sort of 3 steps. Any questions? You know, this problem looks like a pain. Have you guys tried it yet? I mean, I didn't either. I just said, damn, that looks good. I'm not giving them that problem. But again, I don't know. It's just, I think it's just a pain, maybe. Maybe it's not even that much of a pain. But this definitely is a piecewise function. I mean, what's going on? It's rental car sales as a function of the number of days the car is rented. Write the step function. What they mean by that is it's sort of a piecewise function, I think, that gives the rent as a function of the number of days rented for x between 2.5 and 12. And so then they got this chart. If you rent it for 2.5 to 3 days, that's kind of weird. Half a day, whatever. That's the rent. If you rent it anywhere from 3 to 6 days, there's the rent. If you rent it from 6 to 9 days, not including the 9, you got to be careful, not including the 9, like 8.9 days or whatever, then that's the charge. I mean, this is just a chart telling me about how to rent this car. Now, what they want me to do, I guess, is write it as a function. Oh, okay, they don't even want me to do much, but just take those thoughts and write it in this piecewise function. Well, this ain't hard at all, actually, now that I read it. I mean, what do you do here? I mean, what do you fill in up here? What is the rent when x is greater than or equal to 2.5 but less than 3? I think when x is there, I should put the rent. What's the rent?
22.04.
2204. When it's this rent, 3935, x is between 3 and 6. When x is between 6 and 9, and when x is between 9 and 12, I got these other rents. I can just fill these in. Yeah, okay, that was easy. One of the other ones was harder. Let me see which one it was. This one maybe was kind of, no, it still wasn't that hard. I did this one already. Yeah, this one might be a little tougher. That last one was kind of easy, but again, it's kind of a piecewise situation. Again, we're talking about postage here. For the first ounce or fraction of an ounce, it costs 41 cents. Each additional ounce or fraction of an ounce costs 24 cents. So that means, hang on, between 0 and 1 ounces, what's it going to cost? Between 0 and 1 ounces, what's it going to cost? I think it's 41 cents. Do you guys agree? Okay, you just didn't want to speak up. I think that's what that says. Between 0 and 1 ounces, it costs 41 cents. That's what a letter, that's what postage costs. So is there, I got to choose which of these damn functions tells me that correctly. You know, so it could be, looks like it could be that one, or that one. Anyway, what happens after 1 ounce? As soon as you go over 1 ounce, you're going to have to add 24 cents to it. What's that? 65 cents? So now it's 65 cents. For anything between, what? Between 1 and 2? Yeah, because the next additional ounce is the second ounce. Right, it's going to be 65 cents. I think this might be it. Between 1 and 2, it's 65 cents. Look, I don't think it's this. I mean, well, they're trying to confuse me. I think that's it. And then what happens after another additional ounce? You add another 24 cents for every you add it. So now you're up to 89 cents for the next addition, for the next ounce. Between 2 and 3 ounces, it's 89 cents. Yeah, I'm pretty sure that's the function. But I kind of had to figure it out. Well, it was multiple choice. I had to figure it out and choose the right one. Cool. So now that I got that, can I answer these questions? Find P of 1.3. Find P of 1.3 and explain what it means. Well, okay, if it's 1.3, what do I do? I have the function right here. If it's 1.3, what do I do? It's between 1 and 2. It's between 1 and 2 if it's a 1.3. So if it's between 1 and 2, the answer is it cost me 65 cents. Right, okay. Let's see what happens. 65 cents. And it means what? It means the postage on a 1.3 ounce letter? Yeah. The postage on a one is 65 cents. Yeah, cool. Give the domain as it is defined above. That's kind of interesting. What do you think the domain would be? Let me find my function again. What do you think the domain is? The domain is the x values. I feel like, according to this function here, yeah, and even if I read the problem, I should have read the problem. Only it goes up to 4 ounces. So after that, I don't know what they do. It's free. Maybe it's free after that. I think the domain is the x values, and I think this problem ends at 4 ounces. So I think the domain is 0 to 4. I think I can be anything between 0 and 4, is what this says. But I'm paying attention to the x values because it asked me about domain. They want me to, let's see what they said. They said type an inequality. So I'm going to type 0 is less than x. I'm not going to say equal to 0 but then I'm going to say that's less than or equal to 4. This is my x between 0 and 4. I typed it in like I think they wanted to. I think I can find these. If I go back to my cool function I picked, I can find what happens when it's 3. What happens when x is 3? Actually, when x is 3, can you tell me? What is it?
89.
It's 89. So what if it's a teeny bit more than 3?
Then it's 113.
Then it's 113, right. You can read these directions, right, you guys? Read where it says what x is. Okay. All right, enough of that. Enough of that. Enough of that. Anything else in this 3-3 caught your eye? That's another variation problem. You can handle that. This is this. Again, this is a couple of these in your homework. I kind of told you, I'm not putting this on the test. This absolute value stuff won't make it to the test. I think you could plot some points and figure out that graph. This was easy. Do you know the answer to this? You know the answer to this? Concave up, concave down.
Up.
Up,
Down.
down. This had to do with, this is not really a parabola. So sometimes they ask that concave up, concave down question when they give you a parabola. Although that's not the way I talk. When they give you a parabola, sometimes they can ask you concave up or concave down. I didn't talk like that. I said, does it open up or open down, is what I said. Anyway, so what about this parabola? Does it open up or open down?
Down.
Because of the negative sign, it opens down. If it opens down, that is concave down. That's true. But this is a different question. This is about, I tried to teach you one time about the power, and that when the power is 1, like x to the first, it looks just like this. But when the power is higher than 1, it bends this way, which is called concave up. And that happens when the power is higher than 1. What's this power? This power is 5 halves. This power is 5 halves, which is 2.5. Because that's bigger than 1, it's going to have this kind of a look, which is concave up. If it was 2/5, when the power is less than 1, you're right, it kind of bends this way. Right, when the power is less than 1, and that's concave down. Right. It's just a funny little idea I explained to you one time, and you got to practice a couple problems, and you got it. Right. Right. Right, like that. Okay. All right. I already practiced some of this stuff for you, with you. Let me, I'll give you back your quiz, and we can talk about any of that you might want to. Some of you did pretty good. I got a little picky on 1 or 2 of you. Might not have shown me enough work, I think, but I'm not sure. Maybe you were using your calculator. I need you to show me work. If your calculator's giving you the answers, that's not really what I'm interested in. Haley, yeah, you were showing me work. You weren't really showing me much work. Did you have some work? You were kind of using your calculator to help you. All right, well, so I punished you slightly, not much. So in the future, you know how to do it, I think. Yeah, so show me your work on the test or quiz or something. The calculator can help you, but if it's doing everything for you, I'm not interested in that. Jessica, Josh, and Jonathan and Corey and Jonathan. Drupal is missing Chase. Yeah, so anyway, some of you did good, some of you didn't do so good on this. This is, it did get a little tougher. You had to know how to find vertexes and quadratic formulas. Let me turn this off a second. What do you think? Can I help you with anything on this? Any particular requests on this quiz? One of the things, I'll tell you what, on this number 2, y equals x minus 4 squared plus 5. So this is one where the vertex is staring right at you, and what is it? It's 4, 5. So you can work with this form, and the answer is 4, 5. That's the vertex. It's staring right at you. It's the opposite of this sign. It is this sign. And watch this. Once you know that, I want to show you something quick here. If it's 4, 5, then that's 4, 5. Here it is. This is the vertex. Now, does it open up or down?
Up.
Because of this positive leading coefficient here. I mean, there's no leading, but it's a 1. It's positive. So it opens up. So now that you know it opens up, look at this picture and tell me the x-intercepts.
None.
None. By the way, if there are none, I want you to write none. I was a little confused. Some people would leave it blank and I wasn't sure what to put. But I don't know. But anyway, if there's none, there's none.
So why did none count?
Well, look at the picture. The main reason is I found the vertex and realized that the vertex was 4, 5, and then it opened up. So once I realized it opened up, I looked at my picture and said, hey, there's no x-intercepts. So I saved myself a lot of work. Some students they tried to find the x-intercepts. Let's watch what happened. So let's say you didn't see this cool trick. This is a cool trick. But if you didn't see it, what would you do? You would try to find the x-intercepts. Okay, watch. If you try to find these x-intercepts, you move the 5 over and you get a negative 5. And you try to take the square root of both sides. And as soon as you take the square root of both sides, you realize that you're taking the square root of a negative number. And that generates imaginary numbers. And we could keep going, but if the question is, what are the x-intercepts, you don't list these imaginary answers. If the question is, what are the x-intercepts, and they turn out imaginary, the answer is none. So, the answer is, but you don't call these x-intercepts. I mean, you call these solutions to the quadratic equation, but they live in the imaginary number world. They are not x-intercepts. They don't show up on this graph at all. So don't call them x-intercepts. Hey, what about the y-intercept? Plug in a 0 for x. It's always easy, but it's a little tougher when it's in this form. Well, it's not much tougher. When you plug in a 0, a negative 4 squared is 16. 16 plus 5 is 21. Wasn't that hard, but you plugged in a 0. And the range was well, look at the picture. What is the range? Greater than or equal to 5, I think. It's this value. That's the lowest value. So that was fun. What about the word problems? I gave you an equation. I don't necessarily want to do all this maybe, but I gave you this equation for the height of an object. I threw an object up in the air, and that's the equation. And then I asked for 3 things. The time it takes, or no. When is it at maximum height? And then part B, what is maximum height? What is max height? You guys are pretty good. There's only a few of you in this class. I teach my other classes, and students had issues here. And so when I was grading this, I would often just write the word vertex here. They didn't understand, for some reason, they didn't understand max height man, please go find the vertex. Of course, the vertex has two parts, and this part is the time, or the x value of the vertex, the negative b over 2a. And this part is the y value of the vertex, which you get after you find this. So they both involve the vertex, but this is the x value, or the t value, and this is the y value. Again, I think most of you got it, some of you didn't, maybe. Maybe that helps. Maybe just that little conversation right there helps. It's not hard. It's the same old vertex from before. Well, let's do it real quick. Negative b, that's a negative 40 over 2a, which is negative 32. That's it. B, negative b over 2a. 40 over 32 is 1.25 seconds. How do you get the y value? How do you get the y value? Plug it in, thank you, right. You plug this x value in, right. Negative 16 times 1.25 squared, 40 times 1.25 plus 80. You know, sometimes I mark your stuff wrong. Maybe I tell you the right answer, maybe I don't. But this, when you work this out, the answer is 105 feet. So. What about part C? Part C says, when does it hit the ground? When does it hit the ground? And I don't know. Again, these are word problems, but you just got to make these words turn into easy math. I mean, I took these words and made it easy math. I took these words and said vertex. I'm going to take this word ground and say set it equal to 0. I mean, that's what the ground means. Set it equal to 0 and solve this equation. I wrote most of this on your quizzes as I graded them. But now you got to do a quadratic formula. I mean, I can take you through it or not, but when you got to kind of correctly do the quadratic formula. You got to have it memorized correctly and then do it correctly. And this answer was 3.81 seconds. When it is one of these word problems, I want the decimals. I don't want the pure exact answers. So this is, even though this is a big nasty quadratic formula, you don't simplify it. You kind of pick up your calculator and you have your calculator help you simplify it. Yeah. And you round off and all that, right? Hey, let's just do the last one, I guess. The last one, I think I gave you a revenue function. I think it was negative 0.5. What the hell was it? It was, yeah, I'm sorry, 282x minus 0.54x squared. I also gave you a cost function. It was 75x plus 138. But my question was not about revenue or cost. My question was about profit. And so you were supposed to find a profit equation. And how do you get a profit equation? Well, actually, the question gave you a hint. Profit is revenue minus cost. So it's this revenue equation. Watch this now. Let me help you. This is not hard. It's this revenue equation minus this cost equation. When you subtract something, I would put it in parentheses and distribute the negative sign. When I distribute the negative sign and collect like terms, this is my profit equation. Negative 0.54x squared. He's just the same guy. This 282 minus the 75 is 207x. And then that negative sign distributes and I get negative 138. So there's my profit equation. And then a bunch of my students, I mean, not you guys, no, I don't know. A bunch of my students went and did the quadratic formula. But you don't need to. This question wasn't about the quadratic formula. That would be interesting. That would be, when does the profit equal 0? That would be interesting, but that wasn't what this question was about. This question was about maximum profit. And if it's about maximum profit, then I need the vertex. And it was two problems. It was the number of units, which by the way is x, that give maximum profit. That was one question. What are the number of units that give you the maximum profit? And the other question was, what is the maximum profit? So both of those are the vertex. It's the vertex. He's the x value of the vertex, negative b over 2a, and he's the y value of the vertex. Right. Right. The numbers were a little weird on this one. 191.667 was the answer here. You could have called, I was accepting a lot of answers, a lot of rounded off decimals, or you could even rounded it to 192. That was rounded off. That was okay. Then you find the profit. Hey, just one more thing, I guess. I mean, I just kind of helped you with your quiz, went over your quiz real quick. I didn't. Do you have any questions? Okay. All right, so the other thing is I might just come out with some kind of a matching question when it comes to this library of functions. You know, there's this shape, 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 and there's this shape. These are my 6 things in my library of functions. Those were the 6 shapes. The 6 equations were y equals x squared, y equals the square root of x, y equals x cubed, y equals the cube root of x. And then the other 2 were y equals the absolute value of x and y equals 1 over x. So, can you match them up if I just had a stupid matching question? By the way, next chapter we'll do more with these things. We need these, and we'll do more with them next chapter. They could have taught them to me next chapter, but they had them in this chapter. That's fine. We're going to deal with them, but we're only dealing with them in a very basic way here. Can we match them up? Do we have these memorized? That's what I'd like to know. And you can, if you don't have them memorized, you can make yourself a chart and plot some points and figure it out. But I got them memorized. Do you have them memorized? Do you remember anything? Let's see. What about the x squared? What do you say when you see an x squared? You say parabola. Which one's a parabola?
The second.
That one. There you go. Okay, cool. Right? Right. So we should know that. And then what about his cousin? I like it. And I called him his cousin. So here's his cousin, and I can identify his cousin pretty easy. You know who it is? It's the square root function. Do you know which one that is? I think it's this one. Because it's a sideways parabola. It's half of a sideways parabola. So cool. I got that matched up. Then there's this cubic guy. I know him. I mean, I know him. I know them all. I mean, he's cubic. He's a little more snaky. He's this one. Do you agree? Mm-hmm. That's your cubic function. And then his cousin is the cube root, which is the sideways snake. He's even snakier than that snake. He's a side. Anyway, he's that. These analogies. These animal analogies don't always work. You guys okay with that? And now I got 2 more. I don't know. I memorized this. I memorized that this is that V-shaped graph. I've got that memorized. He's that V-shaped graph over here. And then by process of elimination, I know what this one is. Another thing I could think about this one, though, he's the only one that has this kind of bad, undefined place. X cannot be 0. We had a huge discussion on that. And that's what that says. This graph lives to the right of 0. This graph lives to the left of 0. But at 0, there is no graph there. And I don't know, that might help you think of that one. Maybe. I'll come up with something. All right, I'll quit today. Thank you for coming and listening. And we'll, you got an online quiz, you got some online homework. It's all due Tuesday. And we'll take a chapter 3 test Tuesday.